Let's practice writing some exponential functions. So we're going to write things in the form y equals c times a to the x. First one says there are initially 42,000 bacteria, and it triples in size every hour. So we have c is going to be the initial amount, and a is going to be the growth or decay factor. Looking at these two numbers, 42,000 is the amount initially, so that's going to be our c. And tripling means we have a growth factor of what number to triple? It's going to be 3. So we're going to write y equals 42,000, our initial amount. We have to write all the zeros because they were written for us here, times 3 to the x in order for it to triple. The next piece says initially a population is at 2,500. So which letter is the initial amount? That one's C. And then it says is decreasing by 2% each year, which is not very helpful. We're given the rate that it's decreasing. We need to change that to be a factor. So when you're given a percent, you need to figure out what the factor would be to call that A. So first of all, we're going to divide by 100 to get it out of being a percent. So we're going to get 0.02. And then we want to figure out, this is decreasing. So should we add 1 to it to make sure that it's bigger than 1? No, that would be growth. So instead of adding 1 to it, we're going to subtract it from 1 to represent decay. So we're going to do 1 minus 0.02 in our calculator, which is 0.98 as our factor. If we multiply it by 0.98, we're only losing 2% each year. So we can write this as y equals 2,500, our initial amount, times 0.98, almost multiplying by 1. We almost have 100% of the population, but just 0.98 represents the 2% loss each year. Lastly, we have the population of California was about 41 million in 2000. So there's our initial amount in 2000 is at 41 million. But it's increasing by 1.5% each year. So it's increasing, which means our factor we're going to make is going to be bigger than 1. And we have to change this to be a factor, so I need to get it out from being a percent. So I'm going to divide by 100. 1.5% divided by 100 is going to give me 0.015. And we want to think, do we want to add 1 to this to make it growth, or do we want to subtract it from 1 to represent decay? So this is increasing, so our number should be bigger than 1, so that it definitely increases. So we're going to add 1 to it, so A is going to be 1.015, so we're going to get y equals 41 times 1.015. That 1 will keep 100% of the population, and then we have 0.015 more. So we have 1.5% growth raised to the x years.